Alright, next up we've got objective 57, which is rationalizing denominators. In general, we can have terms that look like this. We've got 3 over the square root of 5. In math here, we generally don't accept when we have square roots in the denominator. So we have to follow this process called rationalizing the denominator. So we're going to learn that process today. So we use this procedure when there is a square root in the denominator. So an example is right here to the right. We've got 3 over the square root of 5. Can't have that. We've got a square root in the denominator. So we have to follow this process. So let's talk about each step. Step 1 is that we multiply the numerator and denominator by the square root in the denominator. So looking at this one here, what's our square root in the denominator? We've got a square root of 5. So we're going to multiply the numerator and the denominator by the square root of 5. So we have the square root of 5 times the square root of 5. So when we're multiplying this, it might be helpful to write in those hidden ones. So if there's nothing written in front of here, we can assume that the coefficient is 1. Likewise, the coefficient here is 1. Coefficient here is 1. Well, what's the square root of this here? You could add in that hidden square root of 1. So that way, when we're multiplying, we multiply the number in front, and then we multiply the radicals so that we don't get confused. We're just multiplying 3 times 1, and then 1 times root 5, and so on. So let's go ahead and multiply that out. On the top, we have 3 times 1 is 3. We have the square root of 1 times the square root of 5 gives us the square root of 1 times 5, which is 5. On the bottom, we have 1 times 1 is 1, and then 5 times 5 is 25. Okay. Step 2 is to simplify the square root in the denominator. So here, let's simplify this square root here. We have 1 times the square root of 25. Well, you might already recognize that the square root of 25, that's a perfect square. So what times itself gives us 25? Well, that's 5. But in case you didn't, we can always do the jailbreak method. The top, we're not going to touch for now. We're just going to leave that as 3 root 5. On the bottom, we have 1 times, well, 25 can be broken down into 5 times 5. We've got our pairs, so we can bring that out. So then we have, again, on the top, 3 root 5 over 1 times 5, which is just 5. Our last step, step 3, is to simplify the square root in the numerator and or reduce the fraction. So looking at our example here, can we simplify the square root of 5? No. Can we reduce the fraction? So the fraction here, 3 over 5, can we reduce that? In this case, no, we cannot. So our final answer is 3 root 5 over 5. So there's no reducing or simplifying in this example, but we'll see a few examples where there is. Okay, let's take a look at this here. Again, we've got a square root in the denominator, so we have to rationalize the denominator. We've got to follow this procedure here. So step 1, we multiply the numerator and denominator by the square root in the denominator. So we have a square root of 2 in the denominator. So we'll multiply both the numerator and the denominator by the square root of 2. I'll go ahead and write in those hidden ones. So we have 1 root 2, 1 root 2, 1 root 2. This becomes 4 root 1. So we multiply numbers with numbers. We have 4 times 1 is 4. And then root 1 times root 2 is 1 times 2 is 2. And then in the denominator, we have 1 times 1 is 1. 2 times 2 is 4. So we have square root of 4. Step 2, we simplify the square root in the denominator. So I'm just going to rewrite the numerator, 4 root 2. And then we simplify the square root of 4. So we can break it down. The square root of 4 is 2 times 2. We've got our partners, our pairs, so we can escape the square root jail. And then we have 4 root 2 over 1 times 2, which is 2. Our last step, we simplify the square root in the numerator. Can we simplify a square root of 2? No, we cannot. And then we reduce the fraction. So we're looking at this here, 4 over 2. That reduces to 4 divided by 2 is just 2. So our final answer is 2 root 2. Let's try one more example. Here we have 4 root 8 over root 3. So again, we multiply the numerator and denominator by the square root in the denominator. We've got the square root of 3. So we'll multiply by the square root of 3 over the square root of 3. I'll go ahead and draw in those hidden ones. So we have 4 times 1 is 4. 8 times 3 is 24. So we have 4 times the square root of 24. All over 1 times 1 is 1. 3 times 3 is 9. So we have a square root of 9. Then we simplify the square root in the denominator. So we have, in the numerator, we'll just leave that. In the denominator, how can we break down 9? Well, 9 is 3 times 3. So we have the square root of 3 times 3. And again, we pull out those pairs. So we have 4 root 24 over 1 times 3, which is 3. Now we simplify the square root in the numerator. So we can simplify the square root of 24. So let's go ahead and simplify that. We've got 4 times. How can we break down 24? You could say that it's 6 times 4 all over 3. And then we've got, let's see, 6 can be broken down into 3 times 2. 4 can be broken down into 2 times 2. Oops, 2 times 2. All right, do we have any pairs? Yep, I see a pair right here. We can pull that out. So this is equal to, this is equal to 4 times, we pull out that pair of 2's, 2. And then what's left inside? We have just a 3 times 2, so that's our root 6. And that's all over 3. And then the last step, we have 4 times 2 gives us 8 root 6 over 3. Can we simplify or reduce this fraction? Well, root 6 can't be simplified. And then 8 over 3, we can't reduce that fraction. So this is our final answer. We're going to get more practice on this. This is objective 57.